So now we're going to look at the volume of those composite figures, and the first one of those is a hemisphere with a cone. All right, so we know that the volume of a hemisphere is going to be 2/3 pi r cubed, and then we need to add that to the volume of the cone, which is going to be 1/3 the area of the base times the height. And of course, the base of a cone is going to be a circle. Okay, so the volume of this composite figure is going to be 2/3 pi, my radius is 5 cubed, plus 1/3 times pi times the radius squared times the height, and the height of our cone is going to be 12. All right, so when we find the volume of the hemisphere and simplify all that, round to the nearest tenth or so, we should get 261.8 cubic feet. And then we need to add the volume of the cone, which is going to be 314.2. Okay, so when we add those two together, we should get 575.96 cubic feet. If you round to the nearest tenth, that's going to round up, so it'd be 576 cubic feet. Okay. Our next one has a cube with a cone cut out of it. Okay. So the volume of the cube is pretty easy. It's just going to be the 5.1 to the third power. And then we need to subtract the volume of the cone from that. So it'd be 1/3 area of the base times the height. So the volume of the cube is going to be 132.65 cubic meters. And I'm going to subtract 1/3. Okay, so if each side of the cube is 5.1, then the radius of the cone is going to be 1/2 of 5.1, which is 2.55. So 1/3 radius squared times pi, and then I'm going to multiply that by the height, which would be the 5.1. Okay, so 1/2 of 5.1 is 2.55, and then we are going to subtract the volume of the cone from the volume of the cube. So the volume of that composite is 132.65 cubic meters minus the volume of the cone is going to be 34.73 cubic meters. And when we subtract all that out, we're going to get 97.92 cubic meters as the volume of that composite shape. Okay? And then finally, we've got, I say finally, there's a couple more on the next page actually. We've got a prism with a pyramid on top. So I know that the volume of a prism is equal to the area of the base times the height. So the volume of the prism is going to be 24 squared, because it's a square base, times the height, which is 15. And then I need to add the volume of the pyramid, which is 1/3 the area of the base times the height. So the volume of the pyramid would be 1/3 24 squared times 9. Okay? So the volume of the prism is going to be 8,640, and I'm going to add the volume of the pyramid, which is 1,728, and that's all in cubic feet. And when I add all that together, I'm going to get 10,368 cubic feet. All right? Now, when we look at the next page, here we've got a cone that has the top of it cut off. Okay? So we want to find the area of the shaded cone. So what we could do is we could find the area of the entire cone and subtract the area of the upper cone that's been shaved off, and then that would give us the area of that shaded part. Okay? So the big cone, and you know the volume of a cone is 1/3 the area of the base times the height. So the big cone is going to be 1/3 pi, the radius squared, times the height. Now the height of the big cone is 6 plus 9, which is going to make it 15. Okay? And from that, we're going to subtract the area of the smaller cone. or sorry, the volume of the smaller cone. So the volume of the smaller cone is going to be 1/3 pi times 3 squared, and the height of that one is 9 times 9. So what we need to do is we need to find the volume of both cones, subtract the volume of the smaller one from the bigger one, and that'll give us the volume of this composite shape. So the volume, 1/3 pi times 5 squared times 15 is going to give me about 392.7, and then I'm going to subtract 1/3 pi times 3 squared times 9. That's going to give me 84.82, and so whenever I subtract all that, the volume of the shaded cone, part of the cone that's left, is going to be 307.9 cubic inches. Okay, this last one here, it says the sphere fits snugly inside of a cube with 4-inch edges. What is the radius of the sphere? Well, the radius of the sphere would be 2 inches. Okay, it'd be half the length of the diameter. The diameter would be 4. So, and then it asks the volume of the space between the sphere and the cube. Okay, well, I know the volume of the cube is equal to 4 to the 3rd power, base times height, or just simply one side cubed. All right, and then I need to subtract the volume of the sphere from that to get the space between the volume of the space between the cube and the sphere. Okay, so minus 4/3 pi r cubed. Okay, so the volume 4 to the 3rd power is 64 minus 4/3 times pi times 2 to the 3rd power. When I multiply all that out, I get 35.51 cubic inches. And so when you simplify all this, you get 28.49 cubic inches.